Aloha, this is Tianlu Wang. I'm assistant professor in Department of Mechanical Engineering here at the University of Hawaii at Manoa, and my research is about bio-inspired soft robotics. So essentially, we use the bio-inspiration principle and soft material to design new robots which look like animals. You may have heard of biomimicry or bio-inspiration. It's actually a very long history technology people have utilized to design engineering systems. So if you look into this high-speed train in Japan, Shinkansen, actually the shape of the coach is actually designed according to the big shape of a bird, because that kind of specific bio-inspired shape can help you to reduce the resistance from the wind. So very similarly, right now we are using this bio-inspiration principle to design new robotic systems. So two of the representative works we are currently focusing on is jellyfish robot and stand-shaped robot. 70% of the coral reef in the US water is located in Hawaii, and they are now endangered. So we need a better solution, to deal with this ongoing disaster. Basically, we designed a robot looking like a jellyfish. And this new type of underwater robotic systems can be potentially used for environmental monitoring purposes and environmental remediation applications. This is our current prototype for the jellyfish robot design. So it's actually fabricated using very cheap and user-friendly material. So for example, for the soft pouch, which is the major component for the robot actuation, is just the material we are using for food packages. So it's very cost-effective. So by properly designing the pouch shape and also patterning these rigid components on the robot, which as you can see is also modular, we can detach it. And when we increase the pressure inside of these soft bags or the soft pouches, we can properly generate this bending motion. So the jellyfish-like swimming can be performed. Of course, there's another way to think about this structure, right? It is essentially also like a gripper. So if there's something in the hard-to-reach regions in the ocean, such as coral reef, we can properly deliver the robot there and use this grasping function to take away the garbages or biological samples. So for the stand-shaped robot, actually we developed it for the medical applications. It can be deployed in the distal neurovasculatures to deal with different diseases and to help medical surgeons and doctors to ease the difficulty to access these really hard to reach and distal vasculature regions. Essentially, we are using very similar technology, which is bio-inspired soft robotics, but we design something in the millimeter size. So sometimes we call it a microscope robot. So it's basically composite material of magnetic particles and also soft material. So the function of this robot is that it can be used for accessing the hard-to-reach and distal regions in the brain vasculatures. So potentially it can be used for dealing the medical diseases in this region. I was always fascinated by nature, animals, plants, everything in nature. I always feel like I can get a lot of inspiration from the nature because you can convert your imagination and also your idea into this real product to tackle the ongoing challenges seen globally, like this crisis seen in the coral reef or even climate change, and robotics is a perfect fit for these purposes. So if you are interested, I think biomimicry and bio-inspiration is a perfect job. Robotics in general is like a very emerging scientific field, so there's a lot of opening opportunities, including both industry and academia. So I think this is the perfect time for undergraduate students, high school and middle school students to pursue this career path. As you see, Hawaii is like in the center of Pacific Ocean, right? So there's no land surrounding us like within maybe 5,000 miles or something. So actually a lot of local jobs are about ocean or marine industry. In aquaculture, for example, and marine explorations and environmental remediations. Hawaii is very unique in the sense that we are covering a lot of climate types. So if we can develop a successful robotic system here, we can translate this technology for other communities. While I work on robots in water environment, you can build robots for any environment. If you enjoy creating, problem solving, or even just playing with Legos, you're already thinking like an engineer. Robotics lets you turn your imagination into real-world solutions for the things that you care about in the world.